Welcome to the chapter on tries. A trie is a tree that branches on single characters, so words that share the same starting letters, a prefix, share the same path down the tree. This makes prefix questions fast, like finding every word that starts with the prefix pre. The cost depends on the length of the word, not on how many words you store. Let's start with why tries exist. We will see one question that a hash set answers slowly and how a trie fixes it. A trie branches on characters, not on whole keys. By the end of this chapter, you will be able to do 5 things with one. First, you can trace a word insertion. You follow the trie one character at a time, and you create new nodes only where they are needed. Second, you can tell a stored word from a mere prefix. A prefix is just the starting letters of a word. You check the is word flag, not just whether the path exists. Third, you can count nodes and reason about sharing. You will see why the words cat and car reuse the same first 2 nodes. Fourth, you can state the cost of insert, search, and a prefix query. Each one is big O of L, where L is the length of the word. It does not depend on how many words are stored. Fifth, you can read one node's memory layout. Each node holds 26 child pointers plus a flag, and that is why tries use a lot of memory. The main idea of this chapter is simple. A trie's path spells a key, 1 character per edge, and 2 words that start the same way walk the same first nodes. That sharing is where all of a trie's power comes from. Think back to the hash set from chapter 13. It is very good at one question: is this exact key stored? It answers fast. Compute 1 hash, jump to 1 bucket, and look once. Ask it contains of cat. It hashes the word cat to bucket 2, then looks once. The cost is big, O of 1 on average. Ask it contains of dog. It hashes dog to bucket 5 and looks once again. Also big O of 1 on average. For an exact key, hashing is the best tool. You compute the slot and look once. This part already works well, so we keep it. Now try a different question. Which words start with the prefix pre? A hash spreads keys on purpose, and that spreading is about to hurt us. The table shows 8 buckets with 1 word each. There is apple, cat, dog, and sun in some of them. The 3 red cells are our matches: press, pretty, and prefix. They all start with pre, but the hash flung them to buckets 1, 4, and 6 as far apart as it could. So there is no shortcut. To collect every word starting with pre, you must scan all n buckets and compare the first characters of each word. That is big O of n times L, for n stored words of length L. A hash spreads keys evenly so no 2 collide. That same strength is why it cannot group by prefix. It has no idea of what is near cat. Ask a prefix question, and big O of 1 turns into a full big O of n times L scan. The fix is a trie. A trie stores words by their characters, not by a scrambled whole key hash. Every word that shares a prefix shares 1 path down from the root, so all the pre-words sit together on the same branch. Now the prefix question becomes a single walk down that branch. That is big O of L, where L is the length of the prefix. It does not depend on how many words the trie stores. Same data, different organization. A hash is good at, is this exact key here? A trie is good at, what continues from here? The scattered big O of n times L scan becomes 1 big O of L walk down a shared branch. Let's look at 2 everyday ways to picture a trie. Both make the same idea feel familiar. The first is autocomplete or predictive text. You type a prefix, and the app walks down the matching branch and offers everything below it. The neat app hides the tree, and it hides that the cost is the word length L, never the number of words. The second is a branching phone menu. Press 1 for this, then 2 for that. Each key press takes you down exactly one level toward your goal, narrowing the choices. But a phone menu has only a few options per level, while a trie node pays for one slot per alphabet character, which is costly for a big alphabet. Both work the same way. A prefix, whether letters typed or keys pressed, walks you one step per symbol down a branching tree. Everything below is your set of answers.